All right, ladies and gentlemen, welcome to your video lesson today on lesson 4.3, modeling with arithmetic sequences. Today is all about exactly what that title is. We are going to be modeling real-world situations with our explicit rule that we learned last class. So without any further ado, let's get into the warm-up. Okay, here it is. For Carl's birthday, his parents gave him a $50 gift certificate to a local movie theater. The theater charges $6 admission for each movie. How can Carl use an arithmetic sequence to determine the value left on his card after he sees each movie? All right, so part A says to write an explicit rule for the arithmetic sequence and use it to determine how much value is left on the card after he's seen 4 movies. Now, remember, let me get my right pen here that I like. Remember that an arithmetic sequence is f of n is equal to, and then f of 0, that is just the 0th term, plus the common difference times n, and n would be like 0 for the 0th term, 1 for the first term, 2 for the second term, and so forth, right? So what we have to do is figure out values, right? We need to know what the common difference is, and we need to know what the 0th term is, okay? So when you think about the 0th term, you got to think about what happens before, or I should say maybe what the value of the card is at before anything happens, right? Before I go see any movies, I've seen 0 movies, right? F of 0, that makes sense? So f of 0 would be 50, right? Because I haven't seen any movies. And my common difference, now sometimes students think that this is always positive, and I mean, we're adding, right? I'm taking money out of that card. So it's negative $6. My common difference is negative 6, which means that my recursive rule, my explicit rule rather, I couldn't find the word. My explicit rule would be f of n is equal to 50 plus negative 6n. So 50 being how much money I have in the card, and then subtracting $6 for n, which would represent the amount of movies that I've seen here. Okay, so that would be the rule. Now I am asked to find the value of the card after I've seen 4 movies. Well, all I have to do is substitute in 4 in for n, and negative 6 times 4 is negative 24, and then 50 minus 24 is 26. Okay, so again, n here is the number of movies seen. Kind of get cleaning this up, and we can write a sentence at the end that says he will have $26 left after he's seen 4 movies. Just kind of cleaning this up. Boom. All right. Then this is another interesting question. How much money is left on the card after Carl has seen the maximum number of movies? Like, he's only got 50 bucks, right? So he can't see an unlimited amount of movies. How much is that? Well, if movies are $6 a piece, I can do some simple math in my head and just figure like, well, how close to 50 can I get, right? I can't get 50. The 50 is not divisible by 6. What I know is that 6 times 8 is 48, right? And what that means is I can use the function evaluated at 8. So if I do that, then 50 is, my 0th term. 8 goes in for n, and then I do that, negative 6 times 8, which would be negative 48 here, right? And then we would combine the two. 50 minus 48 would be 2. And so what we can say is that after seeing 8 movies, he will have $2 left. Okay, so again, this is my arithmetic sequence that I would use to find the values of term. My 0th term is 50, right? My first term would be, if it's $6, it would be 44. And then I can find my second term, third term. We just found the 8th term, right? 8th term is 2. So that would be what my sequence would look like. All right, so again, 4.3, modeling with arithmetic sequences. Bunch of examples. Let's get ready to rock. All right. We have an explore problem here. So you can explore real-world situations and solve problems using models of arithmetic sequences. For example, suppose watermelons cost $6.50 each at a local market. The total cost in dollars of n watermelons, so we're going to be using n for the amount of watermelons here. The pen I like. So n is the amount of watermelons, and we can use the the equation here, or I'm sorry, the equation C of n is equal to 6.5n. Okay. So it says to create a table of values for 1, 2, 3, and 4 watermelons. Well, if n is the amount of watermelons and C of n is the cost of those watermelons, the cost of one watermelon is $6.50. The cost of two watermelons is $6.50 times 2, which is 13. Three watermelons would be $19.50, and four watermelons would be $26. So there's my table, just adding. What is my common difference? I think it's pretty clear that my common difference is $6.50. Now, this is another kind of blast from the past question. What are the independent and dependent variables? Remember, these are still functions, right? We're just calling it different stuff because we're relating it to a sequence. So the independent variable is, remember, what goes into the function. Well, what's going into the function? It's the amount of watermelons, right? So I have I here for independent variable. Its independent variable is n is watermelons, right? And then the dependent variable would just be the cost of those watermelons. So D here for dependent variable is the cost of the watermelons. That's represented by C of n. So what is C11? What is the meaning in the cost? Well, C of 11 would mean I'm buying 11 watermelons. So I'm going to substitute 11 into that function that we used here, right? 650 times 11. And when I do that, I end up with $71.50. And I can write a sentence that says that 11 watermelons cost $71.50. All of these real world questions are going to ask us to write a sentence that means or tells us what the answer represents. That's what we want when we do a real world problem. This is another question we ask a lot when we're doing real world problems. What is a reasonable domain? What are reasonable numbers that we can use for what's going into the function, which is n, right? Well, it might be easier to think of what might be unreasonable. Well, if I answer that question, I might think, well, negative numbers make no sense, right? And I probably can't buy partial watermelons. Sometimes you see them in the store, right? But it's not an unlimited amount of partial values. Like, it's probably impossible for me to go to the store and be like, hey, grocer, I want 0.0456 pounds of watermelon, whatever, right? So the best way to probably say this is that the reasonable domain for the situation are whole numbers, right? Now, I know you can buy half watermelon and things like that, but we're going to make this as easy as possible in this particular situation and say that they're whole numbers, meaning I can buy 0, 1, 2, 3, 4, but I can't buy partial pieces. But we are going to forego the fact that, yes, you can buy half, and I don't think you can buy a slice. I don't think I've ever seen that, but that's what we got. All right. Okay. Another modeling problem here. So it says construct an explicit rule and function notation for the arithmetic sequence represented in the table, then interpret the meaning of a specific term of the sequence in given context. So basically, here's the sequence, write a rule, use the rule, interpret the meaning of your answer. That's what we're doing. All right. So the table below shows the cost in dollars of postage per ounce of a letter. So one thing I added here is this 0. In your table, it might not be there, but we added 0 for the finding of the 0th term. Now, if I'm supposed to write excuse me, I'm getting back my pen here. I'm supposed to write an explicit rule. That means, again, I have to find the first term, right? And I have to find the common difference. So the first term is easier to find if I find the common difference. So the common difference would be subtracting 0.55 minus 0.35, which ends up being 0.20. My common difference is 0.20, and as I add up, I can see that that's the case. Now, if I want to go back to find the 0th term here, what that means is that I have to subtract 0.0 from 0.35. And when I do that, I end up with 0.15. So my f of 0 is 0.15. Now, I don't think you have this in your notes, so I kind of crossed this out. This is our explicit rule here, and now I found this, and I found my common difference. So I have all I need to write my rule. So my explicit rule is f of n is equal to the value of the 0th term plus 0.2, which is the common difference, times n. Then it's asking me, what is the f of 11? What is f of 11? And what does that mean in context? Well, mathematically, it means that, well, I substitute 11 in for n. Right? So I do my calculation, I substitute it. 11, that's 11, by the way. I know it looks like an N, but it's really bad written 11. And then I end up with 0.15 plus 2.2. And my final answer is $2.20 here. And what does that mean in the context of the problem? Well, that means is that it cost me $2.20 to send an 11-ounce letter. All right, chugging right along here. Lose sight of the fact, again, this is just a function that we've changed into sequence kind of jargon here, calling it an explicit rule, right? Calling it an explicit rule in which we can use to generate a sequence by substituting in 0 and then 1 and then 2 and then 3 and so forth, right? It's got meaning though in this situation. All right, so same exact directions, and let's look at the table. The table shows the distance in miles from the store after Mila has traveled for n hours. Okay, so we got a table, and then for h here, time in hours is represented by n, and we have 0 hours that I added 1, 2, 3, 4. And then we have distance that Mila is away from the store, and so we don't have 0. We need to figure that out, but we have after 1 hour it's 2, and then 32, and then 44, 56, and so forth, right? So finding the common difference, we're just finding the difference between two consecutive terms, and when we do that, 30 minus 20, that ends up giving me 12. The common difference. Then I have to use it going backwards to find a 0th term. And so if my common difference is 12, that's going to be taking 20 minus 12, and 20 minus 12 is going to be 8. So my f of 0 is 8. So now I have the two things that I need to write my explicit rule. So my explicit rule for this, I'm going to use it and find f of 10. My explicit rule is 8, which is my f of 0, plus 12n. And now I'm going to use it to find f of 10 and figure out what it means in context. So I substitute 10 in for n. 12 times 10 is 120, plus 8 is 128. And what does that mean in context? Well, what it means is that after 10 hours, Mila is 120 miles away from the store. All right, next example. Same instructions, but now I don't have a table. I have a graph, right? And remember, from any table that we have, we can always make a graph. I'm sorry, I said that backwards. From every graph, we can always make a table because we have x and y values, or we can say f of x and x for those respective values. And so for this one, we can say we have 1 and 18 and 2 and 37 and so forth, right? But we have the table. And really what I could also do is kind of visualize that and say this is going to be x and this is going to be y, and it's kind of going in this direction instead. That's not a real great way of doing it, but you kind of get the way that your brain should be seeing it. All right, so common difference here. What I'm going to be looking at is how does my y value change from one to the next? Well, it goes up, which means I have to subtract 37 minus 18. 37 minus 18 is 19, so my common difference is 19. Then I have to find my f of 0 in order to write my function, right? And again, I crossed out this because that was our old way of doing it in the past. We're not going to do that this year. So now we're going to look at f of 0. And so this one, it actually, truth be told, this is a bad example from the book, okay? Because look at what happens. I'm going to end up taking 18 and subtracting 19 to get my f of 0. Well, I get a -1, right? And if we don't think about the context of the problem, we're just like, whatever, we'll use it and it's fine. But if you think about the context of the problem, it's like, how in the world do you have -1 pens if that's the situation? By the way, if we read this situation, it says DeAndre is collecting feather pens. The graph shows the number of feather pens DeAndre has collected over time in weeks. According to this pattern, how many pens will he have after he's been collecting for 12 weeks? Should have read that at the beginning. So the -1 represents how much he had before he started collecting, which doesn't make much sense. But we're kind of we're gonna give the book a pass on this and just gonna roll with it. Okay. All right. So now we have what we need to write our function here. Write our explicit rule. We know our common difference is 19. We know that our first or our 0th term, by the way, is -1. So we can write our sequence or our explicit rule. F of n is equal to -1 plus 19n. All right, so questions about it now. How many pens will he have collected in week 12? Well, that just means n is going to be 12. So 19 times 12 is what we have to substitute first. I get 228. 28 minus 1 is 227. And so what does that mean in the context? That means we have to write a sentence. So it says after 12 weeks, DeAndre will have 227 pens. All right. So again, we're going to give the book a pass on that one. It really doesn't make much sense. That's all I'm going to say about that. We can dive a little bit closer into that, but I don't want to confuse you guys. So we're just going to roll with it. So same directions, different type of scenario here. So it says the graph at the right shows the height in inches of a stack of boxes on a table as the number of boxes in the stack increases. Find the height of the stack of 7 boxes. So we're going to write an explicit rule. We're going to find a common difference, and then we're going to find our 0th term. So the common difference, again, looking at the graph just like last time, I'm going to look at my y values. So 34 to 51, 51 to 68. By the way, I know that there's arithmetic because they're telling me that, right? So I don't have to figure that out. I'm just using that fact. All right. So, and this is the number of boxes on the x-axis. This is the number of boxes on the y-axis. The height, rather, height on the y-axis. All right. So, common difference, I'm going to take 51 minus 34 to figure out what my common difference is, and the common difference is 17. Now I have to use that to find my f of 0, and on the graph, what we're really doing is figuring out where this next point falls, right? It's going to fall somewhere in here, probably right in there, right? So I'm going to take 34. I'm going to subtract 17 to go back one, right? 34 minus 17 is 17, so it's pretty close to where I had it at 20. So now we have what we need. We have our common difference. We have our f of 0, and they're both the same number. It's just a coincidence. So now I can write my rule. So my rule is f of n is equal to 17 plus 17n. And now I have to find and answer the question. Find the answer to the question. Find the height of the stack with 7 boxes in it. Well, that means n is going to be 7. So substitute 7 in for n. 17 times 7 is 170, which is not correct. I have to fix that. 17 times 7 is not 170. Let's fix that. 17 times 7 is 119. 119 plus 17 is 136. 136. So what does that mean in the context of the problem? Can't be awesome all the time. Made a little mistake there. No big deal. Height of the stack of 7 boxes is not 117 or 187. It is 136 inches. All right. Moving right along here. So again, another modeling problem. We're modeling real-world situations with all of these. And we're going to write another explicit rule in function notation for the arithmetic sequence to represent the problem and use it to solve the problem, justify and evaluate your answer. And here's the scenario. The odometer on a car has 34,240 miles on day 1, okay? So after a day of driving. That's the day 1 odometer reading. So every day the car has driven 57 miles. If this pattern continues, what will the odometer read on day 15? Okay, so first we want to find the 0th term, right? So we know on day 1, after it's been driven a day, we have 34,240. And so I want to go back a day to day 0, which means I have to subtract, right? So my common difference is 57. We already told that. We didn't have to figure anything out there. But I have to use it to find my f of 0, my 0th term. So my 34,240 minus 57 is going to be 34,183. So that is my f of 0. Now I have, again, everything I need to write my function, my explicit rule. So f of n is going to be equal to that 34,183 plus 57n. And n represents the number of days driven here. So if I want to figure out 15 days, then I substitute 15 in for n. I do that. 15 times 57 is 855 miles. I add that to the existing 34,183 miles on the odometer, and I end up with 35,038 miles on the odometer after 15 days. So what does that mean in the context of the problem, y'all? After 15 days, the car will have 35,038 miles. All right. Next problem. Jim charges a membership fee of $100 for the first month. That includes the fee. I'm sorry, I should read this over. Jim charges each member, $100 for the first month, and that includes the membership fee. and they charge $50 per month after that. How much money will a person spend on their gym membership for 6 months? So, common difference here, no calculation needed. We know the common difference is $50, right? The f of 0, I think, is pretty self-explanatory. If that first month costs a total of $100 and they charge you $50 per month, and that first month includes that membership fee, right? Well, then all we got to do is take that 100 and subtract the $50 per month fee, and we get that the registration fee, or I'm sorry, the membership fee is $50. That is my f of 0, right? So before they can't charge me the full $100 until after I've been there a month, unless they make you prepay. All right. So my f of n is going to be, again, 50 and 50 is just coincidence, but those are what each of those values are. My common difference is 50, and my first term is 50, my 0th term. So then I use that now to go ahead and find the value of 6 months. So that means my n is 6 because n represents months here. So f of 6 is equal to 50 times 6. That's going to be 300. And that's not what I wanted. Where was it here? Right here. There we go. Sorry about that. I don't know what happened there. And then I take that 300 and I add it to 50. I get 350. What does that mean in the context of the problem? What that means is that after 6 months, the membership will cost the gym member $350. All right. So there's some general questions here. What domain values usually make sense for an arithmetic sequence that models and represents a real-world situation? Here's the deal. In most real-life situations, it really depends on the scenario, right? So this is kind of a generalization, but a lot of times what we do is we take domain values that are like our counting numbers, right? So a lot of times in real world situations, what we're doing is modeling how many times things happen, right? And so things usually don't happen 1.15 times, right? They usually happen like 1 or 2 or 3 or 4 times. That's not always the case, right? But sometimes it is. Our domain values usually are whole numbers, and whole numbers are 0, 1, 2, 3, 4, 5. Negative numbers really don't make sense when we're talking about domain for the real world, right? You can't really go back in time. I can't do negative things, so negative numbers don't make sense. Whole numbers is probably the best answer, even though we're going to concede that, yeah, if we have our domain actually being time, well, I can have half of a minute, and I can have a third of a minute, things like that, okay? So, essential question, check in. How can you construct a model for a real world situation that involves an arithmetic sequence? First thing you got to do is find a common difference, right? If it's arithmetic, go ahead and subtract 2 consecutive values, find the common difference. Next thing you got to do is you got to then find that 0th term. So if you find the common difference, work backwards to find what happened or what value you had before anything actually happened. And then when you're done with that, all you got to do is write your explicit rule to model it. F of n is equal to f of 0 plus the common difference times n. Ladies and gentlemen, that is it. I hope that this is helpful for you and that you guys have a good day. Take care.